And here, I'm just going to share my screen and get this up. Chris, are you on the call? Can you confirm that we've got the recording in progress? We do. Great. So, yeah, today I'm so pleased to introduce Myrna Bittner from RunWithIt. And so Myrna's got a really interesting background. She ended up going to U of A and got her MBA. And, well, I guess first you got your BA in English and Literature and Sociology, which is interesting. Then got your MBA. And so Myrna lives and works in her organization, is actually based in Alberta. Myrna ended up started her first tech company in 1992. She co-founded Bittner Solutions, which is a real-time networking collaboration tool, which actually was used by NASA and US West. Then she co-founded a neural net and 3D visualization technology company, did some consulting on the financial side, and then started up an organization called RunWithIt Synthetics, for basically you've been the CEO since 2014, modeling synthetic humans in a whole series of different things, which we're going to get to here in a minute. And I did want to mention that it was interesting. I appreciate that when people basically, give back and are active in the community. And I think it's worth noting that Myrna is basically an A100 member, which is a group of different tech founders that mentor and help different organizations. The community action on mental health and addiction, which I'm sure some of those on the call are familiar and active with in Alberta Health Services. The ICTC Smart Cities Technologies Task Force and the Elk Island Honor Choir board chair. You're active in that, and then the New Horizons Charter School and Alberta Talent Advisory Council. And so, anyway, I think it's not just the presentation is an interesting one, and the fact that you've got such a great background, but also the fact that you're giving back and you're Albertan. So, super excited to hear your story and learn more about the work that you guys are doing. So, Myrna, I think that's happy to pass on the torch here, and you can get started. So, this call will be recorded, or this presentation, and after the meeting, when we get a chance, I will share the YouTube link whenever we get it uploaded.
Thanks, Jesse. Can everybody hear me okay?
Yes, we can. Yeah, sounds great.
Good? Okay, good. And you can see my screen?
Yeah, you betcha.
Wonderful. Thanks for the introduction, Jesse, and the introduction to your world. Really appreciate this opportunity to kind of just talk about my background. I hope that this is kind of a bit of an informal discussion today. When I have the slide deck up, I can't see if anybody is putting things in the chat. So please, kind of break in if you have a question. I don't mean to, kind of dominate. I really want to hear from this community too. And so I'll just take you on a little bit of a journey, because that's kind of what being in this business is like. And take you through a bit of our history, which Jesse has kind of mentioned already, but in a little bit more detail, and then kind of where we are today and what's in front of us. So hope you enjoy. Hope you have a nice coffee in hand, and welcome to my world of synthetics. So a little bit of background. I didn't do this alone. My first tech company started in 1992, kind of between year 1 and year 2 in the MBA program. And it was really, the internet was a year old, and it was super exciting to be able to think about how it could solve problems. And my background in sociology, and I took a lot of psych courses at the U of A, and English really kind of put me in the mind frame of improving corporate communications. So that's kind of where Dean, who's Dean Bittner, is also my co-founder. This will be my third venture with RunWithIt Synthetics, and I decided to kind of tackle the internet and see what we could do with communications. And so our first venture, like Jesse was mentioning, was Bittner Solutions, and we did it out of a basement out by Elk Island National Park. That was when we had to put software in boxes, and this was particularly challenging because we were tackling remote group real-time communications. So we had to put 10 packs in a box and be able to license and ship those boxes. We convinced UPS to come out there and pick them up from our basement suite and ship them all over North America. We had to buy end dials. We had to buy advertising in Macworld. There was a whole kind of wholesale distribution network. And that was really challenging, but super rewarding. And it was interesting because in the ecosystem, in the tech ecosystem, well, there was none. And so there was nobody who really couldn't tell us that we couldn't do it. And so it was a really great kind of learning journey in terms of what you can do. You can get boxes made up. You can be, an expert at graphic layout and design and make documentation, whatever. Nothing kind of stopped us or slowed us down. And we ended up being very successful with some very large U.S. corporations who were very much interested in solving problems with remote communications. We did video conferencing, audio conferencing, shared screen whiteboarding, voting and reporting, you name it, we threw it in there. We went from there into neural net and 3D visualization research. So with an Australian billionaire who was very interested in solving some problems in energy and deep sea submarine construction, but really wanted to look at how they could take unstructured construction documents, for example, and be able to use neural nets to organize them, to sort them, to understand their relevance, their clustering. And that's really where we began our journey into artificial intelligence. So, not only did we do that, but we did 3D visualization. And you have to remember this was in the 90s, so it was kind of a little bit ahead of its time, but it's something that kind of laid the groundwork for what we're doing now and how we're employing it now, which is to do, rather than artificial intelligence, what we call synthetic intelligence. And through a history of kind of being around tech, having big projects that we were pulled into along the way, we continued to kind of evolve our framework and our IP in neural nets and intelligence. And so in 2014, we really started looking at the complexity that systems were facing, and mostly digital systems because that's what we were familiar with. And a lot of those digital systems were facing these realities that were so complex. They were trying to validate AI. They had super scale. They had kind of human behavior and interface behavior. And they really couldn't, no matter what the engineering efforts or quality assurance and testing centers of excellence, they could not seem to deliver to that reality reliably. And a huge amount of time was lost and expense in trying to figure that reality out when they were already live. So we thought, okay, why don't we take what we have and have done and can understand and create what we call synthetic intelligence, and be able to add people and realistic behaviors, mock systems, whatever was required around these systems, and help them face that reality before they arrive there, and see how far left we could shift that. Left meaning back to the beginning of development, where there could really be some critical decisions made in terms of architecture, in terms of performance, and delivery capability, and save everybody a lot of time and money. And we had great fun with that. We were still trying to figure out, kind of our value proposition and how we were going to evolve the technology. And so we had what we called a year of yes, where when we were approached by some fantastic local companies who found out what we were doing, and they were really interested in how we might be able to accelerate their innovation or help them deliver to their markets. Some of them were like DriveWise, was the in-vehicle device-based system. We worked with them. They were facing 1,000% scale, in growth in that year, and really needing to understand and ensure that they were delivering their product to the market, and it was going to deliver safe, and legal driving instructions in time to meet their kind of market commitments. So we got into geospatial environments in that case, and we used our synthetic intelligence entities to model vehicles and vehicle systems, drivers, and in those vehicles looking at those devices and be able to push those around the freeways of North America. And also in that year, we began to really kind of look at what else and what other systems, if we could take device code off of devices like the in-vehicle device-based systems and wrap it and put it in these synthetic environments, then that opened the door to even doing propositional technologies, so technologies that hadn't been delivered to the market yet. And we could look at their implications and their use in this market, and that's where we were trialing out things like emergency event wearables. In 2019, the geospatial models that we had been doing and creating and human movement and infrastructure and interactions between those things really got pulled into the city scale. And we were asked to create the IoT World Expo keynote for Itron, one of the world's largest smart city utility technology companies. And they wanted us to demonstrate how their technology could really help with resilience. And their technologies involved everything from smart streetlights to gas leak detectors to even smart meters on homes that would shut the electricity off if they sensed movement. And a funny story about that was they called them, their smart earthquake meters, but really they had been developed, the accelerometer in these meters, because of theft. So there was some theft detection. If the meter was shaking, it would shut the power off and notify them, but it also happened to notify them when there was an earthquake. So Silicon Valley, as you probably all know, is kind of built on a liquefaction substrate. And they're expecting some, because there's 3 or 4 fault lines in that area, they're expecting some significant earthquakes at some point. And they really wanted to understand not only kind of the static data about the buildings and the building construction and which buildings were more vulnerable, but they also wanted to be able to look at the opportunities. So what would happen when there was an earthquake with the data streams from their smart technologies, with where they had laid their utility lines and their high-powered gas, which unfortunately happened to be under most of the freeways because it was a cost savings to put them there. And they wanted to kind of explore this and see with smart technologies how much of a difference they could actually make. And so we create these kind of live data environments where we can incorporate all of that data information about how the substrate will react during various types of movements of earthquakes. We can also, what you're seeing here is the map is being lit up is not only people on that map, but also the data streams from the IoT devices. And really for us, it was important to be able to put people into this model, and this was one of our larger scale kind of human live models, because as we found out when we were researching for this project to create this environment, that people are significantly impacted depending on how they receive and when they receive information about the status of the earthquake and the condition or the endangerment kind of circumstances that they're in. So we're able to take this area of Silicon Valley. This is a smaller area, but we had to put it on a 150-foot screen, and it had to be kind of visible for people, and populate it with residents and commuters, and really dig into research from all over the world, as well as the U.S., on how people responded during earthquakes, right down to the kind of their biometrics. China and Japan have done, and even New Zealand have done a fantastic job of furnishing research about how in those critical minutes after an earthquake, people move, the stress that they're under, the long-term implications of that stress, what happens when they have pre-existing conditions. They interview people, they video tag. So, I mean, it's really was quite profound how much we could inform our population in this area. And the reason why this was a really unique project to begin our city scale work with was not only could the city and the utility company begin to see that they had all of this data. In fact, they had data about the earthquake, about where the gas leaks were, where there was fire, and where there was damage to transmission lines, everything before, the earthquake was a few minutes old. And there was nothing that they were doing with this data. So beyond knowing as a utility company where they were going to have to send maintenance crews, it was just sitting there. So the opportunity really was to begin to develop some intelligent systems that could not only connect this to the emergency responders who might want to know where there was fire, for example. I think you can see two kind of reddish areas, we call those the hot zones, in the bottom where the intelligent agent system has decided that those are the conditions where there is most likely people in danger. One of them is in an area of Mission College, and I think the other is in a neighborhood called Agnew. And it can use then, and we can figure out in these in silico, so these kind of sandbox environments, how we might be able to connect that to either technologies that are in place or ones that are under consideration. So in this case, it was the battery-powered mesh networks of the utility that they decided would be still up and available after a significant earthquake in this area. And we could actually feed that intelligent agent system information to that battery-powered mesh network in order to relay information to the population in the area that was most in danger, and then begin to map, and you'll see the blue boxes are kind of maps where they have decided that there is a lot of commuters in the area, and it is picking a number of safe passages and being able to direct commuters towards those safe evacuation paths. So really kind of a lot going on, a massive amount of data coming off of this environment, everything from the very specific demographics of people and residents in their homes and commuters, but also then being able to look at the delta. So if we give 8 safe passage routes versus 6, what's the impact on people short-term, long-term? How many people are we, able to impact and improve outcomes? If we're able to have a smart meter for every 4th home, is that enough, to be able to get the data streams that we need to inform the systems where the damage is? It gives you this just really kind of massive playground for manipulating the future. So a lot of people in the tech world say, you should really focus, and this is kind of at the point in our technology where we began to see that this was an opportunity to really kind of go cross-sector, because there are many different sectors that are facing this kind of combination of complexity and risk and uncertainty and change, and I'm sure we've all become a lot more aware of that now. So we get to be involved in some really unique things with synthetics, and rather than create very specific products to date, we have kind of taken a step back to see what synthetic entities and intelligence and modeling and data can do, and where it makes sense, and how it can make a difference. So one of the unique parts about what we do is, and why we chose the word synthetics and synthetic intelligence, is really about being able to model reality. And whereas, I liken it to the synthetic diamond. The synthetic diamond is molecularly identical to a real diamond, and so it can be used for the same purposes, versus an artificial diamond is, looks the same, but really can't be used for the very specific purposes that a real diamond can. And so we set out to pursue synthetic reality because we think that while it is not it's man-made, and while it's not, actually certain and real, that we can get very close. In fact, what we do around the things like synthetic data and synthetic modeling oftentimes create the emergent behavior that people need to see, and that they haven't been able to see when they've been using predictive systems. So more mathematical systems that are kind of trapped in historical data and its limitations or its biases. We can really kind of project forward, make it entirely explainable, manipulatable, create as many entities or different types of entities as we think are relevant, and all of their characteristics. So in a way, it's kind of extending our reality. And we get to explore then all of the what-if scenarios, so kind of move it forward. And one of the interesting parts also about the world of synthetics and synthetic modeling is that we can tackle things like optimization. So our synthetics now, when I talk about cross sectors, are even early in 2021 going to be used in the bioeconomy. So the optimization of some really complex supply chains and physical kind of conditions, accelerating pilots for soil remediation and biomass kind of supply chains and even the economics around those. So really kind of expanding the applications. One of the funnest parts for me, having a humanities background, is synthetic people, and this is a little bit different than what the synthetic data that people have been using, or when it's used to kind of sample historical data and then de-identify it for things like accelerating, COVID research even. What we are able to do is to take population data, so publicly available data, and then really add all of the demographics, the psychographics, the behaviors, the intentions, and then be able to map those back to a population. So while it's not an identifiable population or just a de-identified population, it actually becomes this kind of living population that we can ask questions of and really begin to inform, from who's on that very specific map in that community or that city, policymakers, without violating any privacy issues. And this kind of is part of our 2020 when we looked around at different applications for what we could do with synthetics. Utilities are a big kind of area where there is, they're facing disruption. So energy in particular is one of the things, the kind of fundamental layers of cities, along with health, that is facing disruption. And part of it is that, a lot of them have aging infrastructure. Cities are growing really quickly. There's a profound pressure for decarbonization, so reducing GHG emissions. And there's also a shift towards electrification. So people are looking for ways of, using electric vehicles instead of internal carbon engines. And so it really kind of was an interesting space when we started doing city scales to be able to say, hey, let's look at creating synthetic energy right down to the grid assets and how they function and household consumption, and see what we can do in that space. And it didn't take us very long, and we landed kind of at the top of the energy and utility space with the Electric Power and Research Institute in the U.S., and we were lucky enough to win the Incubate Energy Labs Challenge. So now what we're involved in is projects where we begin to look at whole cities in the U.S., working with some large U.S. utilities, and we're able to map not only the shift, for example, the very human shift in energy that's taken them kind of by surprise during COVID, but we're able to then help them map and understand this new world where humans are the drivers of their grid, and we can do this through synthetics. We can even look at what happens to these people during, not only everyday life, but during disasters. So they're, experiencing a lot of weather events, fire events, and during COVID. And so they really have no roadmap now with what's going to happen to utilities, both during those outages and as long-term effects. So that's what we're able to do with synthetics. And we start sometimes by even delving into the very specific kind of household synthetic data that we can generate. So who's in the homes, looking at tying from generalized population data down to very specific, kind of indications of neighborhoods and households, income levels, demographics, education levels, health levels, and we can tie those even to how they might answer particular surveys. And so this is just kind of a snapshot of some of the work that we have underway, where we can help inform the utility and then really begin to help them understand how these kinds of outages on these specific household layers or levels will be affected during these outages. And so it gives you kind of this massively zoomed in perspective, and they can see who is being impacted during these outages, how they might develop better systems to minimize that output, or those outcomes and bad outcomes, as well as work with the surrounding systems, so the health systems, the emergency response systems, and even the utility cares about who has pre-existing conditions in the area and might need oxygen concentration, electricity during the outages, those kinds of things. So they're really starting to connect the dots because they understand how much of a profound opportunity it is to be able to be a better kind of prepared for the future within their specific cities and regions. Also, as a part of this year, we have moved the synthetics forward into, because we're dealing with energy and electrification, we're also looking at electrified mobility. So we were recently announced as one of the semi-finalists for the Toyota Mobility Foundation City Architecture of Tomorrow Challenge, and this will take place in Kuala Lumpur. So we're going to be furnishing a synthetic Kuala Lumpur along with their grid infrastructure, but most importantly their population, because each city kind of has a very unique population, and they have unique challenges, unique incentives that they need to explore, unique behaviors, and when it comes to everything from the types of vehicles that they're choosing to why they're choosing those vehicles, how they respond to incentive programs, their daily kind of patterns of life and usage, and where they like to plug in their vehicles and how they like to charge them. And these are all things that are quite confounding, because a city like Kuala Lumpur can spend a lot of money to reduce their pollution and their congestion and supply free public infrastructure for charging electric vehicles in their downtown area. And to find out that because they haven't included humans in those models, nobody is using it. And they're not using it because they have very particular kind of patterns of life and ways of thinking about their charging infrastructure that means that they all prefer to charge at home. And so this, kind of approach to modeling enables them to be able to understand those things before they go ahead and build that infrastructure and hope that the people will come. We also do and have dabbled in some really interesting experiments when it comes to how people move in spaces, how they use public transportation, how they navigate buildings and infrastructure. And so this kind of enables us to be able to understand things from a different perspective when it comes to inflections. So in our models, because they're live and we can explore kind of an exponential number of futures, but in in most cases, there's a certain kind of level of complexity where people need to try different combinations of things. So different combinations of, for example, LRT, the size of the cars or the frequency, or during rush hour, or different LRT lines, where the stops are, how comfortable women feel, if the stop is 2 blocks away where there's less lighting, versus closer to a venue where there may be more traffic or more difficulties crossing the street. We can really begin to model these in silico situations and begin to inflect then and see which combinations make the most sense. So this really kind of becomes important, I think, and an important piece in these kind of really complex policy environments, really complex kind of infrastructure environments and planning and design environments. I know we are being called into, not only when we're exploring utilities and energy and the kind of the shift as people have moved, to work from home for utility companies. This also then connects to where people are, how they're using other services, how they're accessing health, where they are having the most kinds of health conditions, why, kind of what the patterns of life are around those health conditions, and then furnishing that access as the utility, if they started this, to other systems as well, really becomes a unique capability. This is just kind of an interesting example of something that we did on our own at the beginning of COVID. We had done some street modeling in Edmonton and traffic and movement, and it was around events. And so this was, we put masks on people then and ran the same model. So understanding how people were commuting, the typical kind of groups that they arrived in and at different stations. And we can, really give these people kind of specific commuter characteristics and understand, right down to mask efficacy. So, we gave them different types of masks, homemade masks, N95 masks. We incorporated all of the studies that had been done to date on the efficacy of those masks, the proximity kind of ratings and risks and issues when they were clustering on streetlights or whether they were on transit in different kind of amounts. And then we were really able to kind of quantify and begin to look at masks before they were made really popular, can I say, by policy. But the difference in the reduction in risk if masks had been used and popularized at that time, and how important that was. We felt it was really quite a important message to get out, and so we did a lot of work kind of just as public service to try and get the message out and to try and quantify it, because I think with these environments it really gives us an opportunity to help demonstrate to all different kinds of stakeholders the science and bring it to life, rather than just have it sit on a report or show a graph during the news. We can actually put people in these scenarios and watch and help people understand. So we had some fun when we were modeling this. Part of it was to give everybody in the city of Edmonton that we were modeling names and characteristics and preferences and experience, so that we could kind of quantify who they were and really be able to see how moving around Edmonton, in different patterns and different lifestyles and with different purpose could make a difference. And then connect that with all of the science around what was being discovered at the time for COVID, around aerosolized transmission, around proximity risk, and put that kind of in context. And of course we can add, as new research becomes available, we can add it at any time. And so when we are dealing in this kind of geospatial world, we don't have to be city scale. And although we can, and that was an important thing for us to demonstrate, but really some of the most interesting things happen in smaller spaces. And so, this is something that we are also really interested in doing and pursuing some different initiatives, modeling interior air quality initiatives and PPE. And I think this becomes really important when you look at, not only households, but also schools and sports venues. Me in particular, I'm really interested in schools at the moment, and that is something that I think in a synthetic model we could really help the population understand, that it's not just the kids who are going to school, but we could show the different cohorts of those children in the communities, maybe the risk factors of their parents, and the demographics that they are in and their patterns of life. And just how much, those cases in the school might ripple out or affect the community. And I think it's really an important time to start quantifying those and exploring those so people have a better understanding of, what different things like the NHL bubble and the schools, really the science of what, the spread might be, or the safety measures and how, putting those safety measures in place, how important they are. So, to really inform that, I think, given the level of discourse right now, would be of interest to us. We have had experience with synthetics in the medical community. We were last year part of the Canada-Chicago mentorship program in it Matter, it's called, in Chicago. And it's a really fascinating kind of concentrated program where we get to interact with the top medical kind of community in Chicago. And we got to work with Northwestern Medicine there and really kind of explore how synthetics could help them, understand not only kind of human-centric or patient-centric care, but also patient-driven care. I think that's the next thing that is of interest to the medical community, although it's kind of threatening at this point, but really necessary to help them inform how they can prepare and build their institutions, even their reputation, and their access to information, because they believe that patient-driven care is on its way, and pretty soon the patients will be making their decisions about, which medical facilities they go to for what procedures, and those will be dependent even on their own probably genomics. And so this is really what we're, kind of interested when we think about the health sector and our work there and evolving it, is really kind of not only its connections to, the kind of the city infrastructure right now and how cities function. It's intricately connected, believe it or not, with the energy sector. When we, quarantine people and we shut them down, this changes the whole dynamics of the grid and creates great distress, for utilities who are trying to grapple with new kinds of forecasting and purchasing of power. But it's also kind of understanding the opportunities to create really kind of intelligent policy and response and preparations for things in the community, and give people a chance to kind of optimize and understand and quantify and compare as we're looking more and more towards how do we re-engage in this new kind of scenarios that we're facing. And be very region specific. I think that's another kind of issue that the utilities are kind of understanding, is that very different responses might need to be made in very different parts of the city. So there's people who can look after their own, kind of power insecurity, and there's people who can't. And that it's really important that that they be able to understand the impacts and be able to change that response depending on the areas. And I think the same probably applies for medicine and medical policy in the province. There's going to be very different responses in some communities to COVID and than others, and that needs to be able to be communicated and understood and trialed, and that the population needs to be able to trust that is going on. So we would really like to be involved in bringing synthetics to this market and in bringing synthetics to medicine. We were talking, I know way back in the beginning, Alberta had a program called Bits and Pieces, and they were really interested in us applying for bits and pieces, but they said they were really just focused at that time, and this was back in March and April, on masks and vaccines. And our pitch towards, helping to model and plan for re-engagement was kind of like, yeah, but, we'll get there someday. But I think all of these things require us to kind of be a little bit more upfront. So even modeling vaccine distribution and administration, I think, is really kind of interesting and challenging kind of scenario that we could tackle. And looking at, we're not epidemiologists, we're just experts in modeling, but we could work with and ingest information about risk and which populations where should be vaccinated and in what order. And so for us, really, we're looking forward to be able to engage in health with synthetics and help prepare for, not only the technologies that are up and coming, but also the policies around those technologies. Because I think we've all figured out by now that technologies, unless they actually kind of are accepted by populations, that they don't go anywhere. So it's not, you build it and they will come anymore. It's you have to engage with people to understand what it is they're looking for in technologies and make sure and trial that you're there. And so that's kind of my presentation for today. I wanted to leave lots of time for questions. I think I have to stop sharing so I can see questions if there are any. But welcome to my world of synthetics.
Such an interesting presentation with so many implications, and yeah, for sure, I can definitely see quite a few use cases in the AHS level, and really in the government in general. With the COVID vaccination, planning and facility planning, we have we have at least 700 facilities in AHS right now that we either own or lease, and just discerning where people should be and where the services should be. Certainly some quite a few opportunities. Abdullah has a question. So can you please explain how bias is handled in your system? Also, how do you handle socioeconomic challenges that exist in a population, and would the model ignore them, mitigate them, or magnify them? For example, parts of the population who are disadvantaged.
Okay, so that's one of the big questions, I think, and why I like our ability to create these very explainable models, is that we don't leave anybody behind. So we were laughing when we did Silicon Valley, for example. We made the population in that core area of high-tech businesses 50% women, because we could, and we could model their behavior. So we can actually unbias scenarios by paying very careful attention to the differences in behaviors, in psychographics, in demographics, if there is any, and unbiased. Whereas typical AI that is trained on a data set, and this is, where kind of the artificial, distinction between synthetics comes in. They are trained on the data set the way it was collected and what was collected. And so that's kind of where we step aside. Instead of us saying, this is the data set that was collected, it was a, potentially biased population, we can look at what the actual population is. And then we can create and make sure that those entities are expressed in their numbers and in their behaviors. And when it comes to disadvantaged populations, so in some of the U.S. cities that we are modeling, there's some real distinctions in income levels, in employment levels, in health and pre-existing conditions. And we can we can place those people on the maps or in the communities that we've matched to the synthetic population, and we can really look at, in particular, those types of people who are impacted the most and what they're impacted by. And then we can draw those kinds of things to the attention of the utility so they can understand where they need to focus their efforts. Much like when I was helping with the Calgary Advisory Council on Mental Health and Addictions, and being able to look at, kind of and map the system and understand who's using it and who needs to be using it. So not only just the data from the people who have accessed the system, but also include the data from the people who haven't accessed the system and what kind of their outcomes and their issues have been. So it's kind of an ability to explore outside of that really kind of constrained data set that most systems are accessing.
Great. There's another question, I think. Who's next? I think Dean's next. Would you consider your approach to be multi-agent system/simulation, and also how many agents can you simulate at one time?
That's a great question. So yes, it is agent-based, activity-based intelligence. You name it, we mix it in. And a very kind of layered and multivariate. It's our entities are kind of reactive and responsive, goal-seeking, they're context-aware. So it really creates this kind of dynamic and emergent landscape. How many agents can we create? We haven't kind of hit the top end yet. We'll probably hit the top end when we hit the top end of the dollar sign on the computing we can access. But we do some extremely large scale environments. So telecom is actually our largest customers, and we do their targeted advertising systems for networks like Dish and Telenet in Belgium and TV. So tens of millions of entities, and each one of those are spinning off thousands of data points a second. So we deal in really large scale environments.
All right, next question is, there's a comment here, and then any comments on agent-based modeling versus synthetic modeling, and is the former what you call trapped in historical data?
So we have encountered some agent-based modeling, some strictly agent-based modeling. Usually it's in the area of like fluid type modeling. So some of them even model people in a city like fluid, or traffic and kind of congestion patterns. They're typically quite simplistic models. So the kind of the detail of the entities or the agents is kind of scoped in or limited. And that's one of the things that we kind of work to explore and go well beyond is in agent-based modeling. So when we describe our synthetics and synthetic modeling, it's like a universe where there is a limitless number of layers in those environments that are interacting, and really kind of in a manipulatable, explainable way, because we're helping some really critical high-value decisions being made, and there has to be a lot of certainty in those decisions. So it's not just kind of a one-time game where we're solving a bullwhip effect in a traffic lane. This is what happens when we manipulate things like communications during an outage. What is the economics around supporting communications during an outage? What are the impacts and quantifying those things, and long-term effects on populations, short-term health effects, outcomes, how that stresses the emergency responder system when communications are down, where is it most critical for communications to be up during an outage? These are the kinds of things that just a simple agent-based, kind of simulation or model doesn't suffice. And did I answer that question? I think so.
Jerry, do you have any follow-ups? Oh, he says he thinks so. Good. Okay. And the next question is for Andrew. You mentioned that you ingest industry survey data for consumer preferences, not just for a specific sample, but for everyone. Are you able to elaborate on how you were building preference profiles for the entire population of interest? And is this through imputation?
Okay. I'll try to explain it this way, I guess. So in some of the populations that we're generating, we have faced a large amount of kind of industry surveys. So these are not industries where they haven't wanted to know what their populations were thinking. They've done an enormous amount of surveys and where we have access to their public data sets. But where their surveys kind of falls down in a lot of their data science is being able to look for, kind of one-to-one correlations and being able to relate those then to any kind of effective, policy or understanding of their population. And so this dates back to our kind of neural net experience in IP, but we're able to use filtering and neural nets and build kind of very detailed responses on top of all of that kind of deep dive profile information that I was showing you about demographics. So we can kind of understand how many people in the population, for example, in the city have experienced outages, how many outages they may have experienced before, how that affects their willingness to pay, where they live, what types of kind of nested kind of behavior and demographic and education levels and health condition levels and family cohorts they're from. And then we can look at these, kind of undescribed data sets from these surveys and map and cluster and filter until we have what we believe their response would be in that household to the survey. So in that way, we can take a survey that may have been done, kind of across the U.S., but map that to a particular population in a neighborhood, household area, even city, that might be slightly different than the sample population in that survey.
And the next question is, has there been any study comparing how well the synthetic models have fared compared to actuals?
So we
metrics
yes.
we
get,
which is a good
yes.
question.
We get that a lot, yes, and sometimes that's one of the kind of sticking points when we are in negotiations too. One of the best ways that I can kind of describe it is the information that we are able to assemble and that people are able to see, and the connections that they are able to make when we spin these environments up is something that they have never had access to before. And can we absolutely nail the future. I would never be as arrogant as to say yes, because but we can get people so much closer. And in some environments, for example, we've had some customers now for 6 years, and they're very kind of critical, deep kind of understanding and future forecasting projects, and kind of the reason why we're still there is because we've done very well at helping them see the future. So that's kind of one of we ride on our record, I guess, and we're positive that what we can show people is far more kind of intelligence, capability to understand, inflect, position, advantage, and plan ahead in these live data environments than they've had before.
And the next question is, what are the main advantages in converting large amounts of input data into actionable insights?
I think that we've been chasing data in almost every industry and every sector. Everybody's been told data is like gold, and yet I think there's a lot of struggle out there to figure out how we can kind of translate that to advantage, and a lot of it I think is because much of it is historical. So for example, when COVID hit, there was a lot of AI systems that
I think we may have lost audio. I'll give Myrna maybe a couple minutes to join in, or maybe one more minute here, just because we're fairly short on time. Natalie, I'm not sure if we do work with them right now, but yeah, we'll wait for Myrna to join back in.
Hi, I'm back.
Hey, Myrna.
I'm not sure what happened.
No problem. Yeah, that's okay. It happens.
Yeah,
could easily be on our side too.
Yeah.
There was a question. Oh, go ahead. Sorry.
Sure. No, go ahead.
Yeah. We're kind of within the last minute here, and when Natalie was interested if you've done any work with Alberta Health Services or the Alberta government.
We have not.
Okay. All right.
Like to.
Yeah, there certainly is.
But we've mostly been kind of consumed by private industry, and so it's my problem, I guess, or my lack of kind of reaching out. But really, that's where we found the most traction, and we're revenue funded and have been to date, and certified Aboriginal business, women led. So we've been kind of just really rapidly chasing the opportunities that are in the private sector to date.
That's great. Well, we're out of time, and I do want to thank you. It's been extremely interesting, and there's so many different areas that we certainly could leverage this kind of technology. It's hard to zoom into one, but I thank you for your time. And what we'll do is we'll record the session. We'll get it out to everyone here shortly. And Myrna, I'll share your contact information, and if anyone has any questions, they can follow up if that's okay.
Perfect. Thank you, everybody, for your time. Have a great day.
Thanks, everyone. All right, have a great day.
Thank you.